Today what we're going to be talking about is the atomic structure or the structure of the atom. And the atom is composed of three different particles that together combined make up one individual atom. So these are known as subatomic particles. The particles are protons, neutrons, and electrons. Depending on what particle you're talking about, they have various differences, and those come from the charge, where they are located, and their individual masses. An electron is the smallest particle. It gives you a negative charge. They're located outside of the nucleus, so they're spinning around the nucleus, and they have what's considered a negligible mass. A negligible mass means even though it has a mass, it's really, really small, and so we don't even really care about it. We consider it basically zero. In fact, you would need 1,800 electrons to equal the mass of one proton or one neutron. A proton, you got to think of pro is positive. So what is a proton? It has a positive charge. It is located in the nucleus and it has a mass of 1. Neutrons are neutral, and by neutral that means it has zero charge or no charge, neither positive nor negative. It too, just like the proton, is located in the nucleus, and it too contributes a mass of 1. So according to masses, protons and neutrons are equal to each other. As far as charges go, electrons and protons contribute towards the charge of an atom. So when we're looking at an atom, if we were to label these, electrons are located on the outside, so we would say that would be the electron there. So this would be the electron, and we do abbreviate it as an E with a negative because its sign or its charge is negative. The positive ones in the nucleus, this would be the nucleus. Those are the positive ones right here. Those are the protons because they are both positive and found in the nucleus. And then the other guys right here are the neutrons. And neutrons have a neutral charge, and they are too found in the nucleus, just like your proton. There are differences between the terms atom and ion, and you will need to know this for your test. An atom is a neutral particle. That means its charge is equal to 0. Okay? So what that means is that the two things that contribute towards charge are electrons and protons. So if you have overall them canceling each other out, then therefore you would have a neutral charge. So if I had, let's say, 10 electrons, that was contributing a negative 10 charge, and I had 10 protons that were contributing a positive 10, overall they would cancel each other out to get a net charge of 0, and that would be considered an atom. An ion, on the other hand, is a charged particle. So the electrons do not equal the protons. Okay, so they do not cancel one another out. A cation, if you break it down, you can say A positive, instead of a T, you can think of a plus sign, ion. Okay, so it's A positive ion. An anion is A, instead of an N, think of the word negative. Okay, so it's a negative ion. So when you break those words down, you have a cation and an anion. Both words have ion, and both mean that they have either a positive or negative charge. So the word ion means that it has a positive or negative charge. A cation, how you can remember it, it's really, really lame, but it's a positive, like a cat. Ion. So it's a positive ion. And what that means is if you have a positive ion, you have more protons than electrons. And the reason why you can figure that out is protons are giving a positive, electrons are giving a negative. So if I have more positives than negatives, my overall is going to be positive. On the other hand, a negative ion or an anion is going to have more electrons than protons. And that, once again, same logic, is that I have more negatives than I have positives. If we were to look at these guys, we're just going to focus on the things that give charges, and the things that give charges are protons and electrons. So the protons found in the nucleus, we see that there's 11 for all of these, okay? That's where I'm getting this count down here. When we look at the electrons, which are around it, I got 10 electrons, 11 electrons, and 18. I literally just counted how many. So what you want to do is you want to figure out what is the overall charge. So if I have 11 protons, that means I have a positive 11 from the protons, and the electrons are giving me a negative 10 because I have 10 of them. Overall, that would be a positive charge. And to be a positive charge overall, that means you would be positive. So this would be the cation. For the next picture in B, I have 11 protons, which means I would have a positive 11 contributed by the protons. I have a negative 11 because of the electrons. So overall, that equals 0. So they cancel out. That means that this would be an atom. And when we look at this next one, I have a positive 11 from the protons, and I have a negative 18 from the electrons. So overall, that equals a negative 7. A negative ion would be an anion. Here are some formulas that you are absolutely going to need to memorize for this test. We will not be providing them. They are so key to knowing the structure of the atom and future lessons, actually. The atomic number, okay, is equal to the protons. Always, 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 always. So if I tell you the atomic number of lithium is 3, I am literally telling you that its number of protons is 3. If I tell you that it has 10 protons, you're going to look up the element with 10, an atomic number of 10 to figure out what the element is. Okay, because protons always equal your atomic number. If you go back to the formula sheet or the subatomic particles and you looked up the two things that contributed mass, that would be the protons and neutrons. Where are they located? In the nucleus. So if you know that, okay, the nucleus is the part of the atom that is going to be contributing all of the mass towards the element. You do need to memorize that your mass number, or the mass of your overall atom, is where you add your proton count plus your neutron count. Remember, electrons have very, very, very negligible mass, so we actually don't include them at all in our mass calculations. All of your mass, once again, is found in the nucleus. And then to figure out charge, you can either kind of logically think through it like I did on the previous problem, or you can use the formula of charge equals protons minus electrons. All of these you need to memorize and be very familiar with. Okay, you do also need to understand how a chemical symbol is written. The mass number is always written in the upper left. The atomic number is written in the lower left. The element symbol, or the symbol that's found on the periodic table, is in the center, written large. And then the charge of that element, so making it an ion, is written in the upper right. So when I ask you to create the symbol for oxygen, oxygen's chemical symbol would be O, so that's why it goes there. It has 8 protons, so if it has 8 protons, that means its atomic number is 8. 7 neutrons doesn't specifically tell you anything other than I now can calculate my mass. Remember, my mass equals protons plus neutrons, so we have 8 plus 7, which makes it 15, and that's why you have a mass of 15 up here. And then to figure out your charge, you know charge equals protons minus electrons. My proton count is 8, my electron count is 10, so I know that I have 2 more electrons than I do protons, and that's where you get the negative 2. You will sometimes see that your charge is written instead of a minus 2, it will be written as a 2 minus. Both are considered acceptable in the chemistry world. Similar to the words atoms and ions, isotopes are also thrown out all the time in the chemistry world. And it's very important that you understand the differences between isotopes and ions and atoms. Isotopes are have the same number of protons and same atomic number as each other. So if I have an isotope of one element and an isotope of that same element, you are always going to be talking about, once again, because they have the same proton and atomic number, it is the same element. So isotopes are always the same element. What is different about these elements is that they have a different number of neutrons and therefore mass number as each other. Okay, what you should do is assume, though, that they have the same number of electrons as protons, so that means its charge would be 0. So if I told you that there were isotopes of carbon, there were 2 isotopes of carbon to be exact. We have carbon-12 and we have carbon-13. This is just another way that we can write its mass number. Okay, what I'm telling you is that they are the same element. Okay, because they have the same proton and atomic number, therefore they're both carbons, but they have a different mass number in neutrons. So isotopes, once again, same element, same protons, same atomic number, different mass, different number of neutrons. So when we look at this problem, hydrogen 1, this 1 represents its mass, and hydrogen 2, this is another way to write it, 2 would be its mass. Which isotope has the highest percent abundance? Meaning we have these different atoms of hydrogen out there. One has a mass of 1, one has a mass of 2. But which one is more common? And all you have to do is look at the average mass that's written on the periodic table. Okay, and in this case, if you looked at the periodic table, its mass, if you looked at hydrogen underneath, it would say 1.00794. And what that's saying is if we average all of the hydrogens out there and we figured out the average mass of all of those hydrogens, which one would be found most often? Okay, well, that would be hydrogen 1. And why? It's because your average is so close to that the hydrogen mass of 1. Okay, 1.00794 is so close to having the mass of 1 as opposed to having a mass of 2. When you look at this problem, what does that 20 mean in neon-20? As I have stated before, that means its mass of that neon is 20, which means if you looked up neon's atomic number, or it would be 10, which means it has 10 protons. If you know mass equals protons plus neutrons, and you know your mass is 20, and your protons is 10 because you're dealing with neon, then to figure out your number of neutrons, it's simple math, and you get 10 neutrons. So what is the difference between neon 20, neon 21, and neon 22? Well, one thing that's very similar is that they all are neon, therefore they have 10 protons. What is different, though, is that their masses are all different. Okay, but since they have the same number of protons, they just need different number of neutrons. So neon 20, as I've already calculated, has 10 neutrons. If you did the same math, you would get neon 21 has 11, and neon 22 has 12. Therefore, they all have different masses, different number of neutrons, but they are considered the same element. When we look at this one, which would be isotopes of each other and why? Very, very important for you guys to understand this. So we've got 3 various options, okay? One thing I know about isotopes is that they have the same number, same atomic number. Well, where's the atomic number written? If you look at your notes from previous, you would notice that this bottom number is equal to the atomic number. So isotopes have the same atomic number. And if I look at this guy with the 19 is not the same as the other guys. So far, it's eliminated down to these 2. But what they do need is to have a different mass. And mass is written at the top. So therefore, if you look at 20 versus 22, they are different. So these 2 would be your isotopes of each other. Hopefully you guys understand the basics on atomic structure tonight, and have a great night.